12.3 pi coloring contest. I'm not going to go over all these instructions because this activity is really not really meant for remote learning, but I think we can still get some more practice with the radians because I think they're not so easy. They're kind of confusing. Okay, so the first thing I'd like you to try and do is, let's call this circle 1. Let's call this circle 2. And the first thing I want you to figure out is in each of these sectors, which you can assume that they're broken up into equal parts. I think it says it somewhere up here. What the radian measure for each angle for these sectors are going to be. They're all going to be the same because they are congruent, all parts. But what will be the specific radian measure? All right, so we know that all the way around the circle is 2 pi radians. We are breaking this circle up into 1, 2, 3, 4, 5, 6, 7, 8 equal parts. So that means I'm going to take 2 pi, I'm going to divide it by 8. So I really have 2 over 8 pi, which is like 1 over 4 pi, or just pi over 4, right? Really, any of these ways are all equivalent. Most commonly, you'll just see pi over some number in the denominator. All right, so each of these are going to be pi over 4. All right, so while I'm labeling that, take a look at circle 2. Using that same logic, what would the radian measure be for each of those sectors? So again, we start off with 2 pi. Now we're going to break that up over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 different areas, which is really just going to be pi over 6. I'll reduce 2 over 12 to 1/6. All right, I'm not going to write all those in there. It's a little bit too small. And I don't want it to look too confusing. I'm realizing it doesn't look outstanding over here. Okay. So I know for me personally, as much as I would love to just be able to think in radians, we just naturally, because of all the practice we've gotten, and maybe radians is just a bit of an abstract measure, but we normally think about things in terms of degrees. So even though I wish I could say like I can understand radians perfectly, things always make more sense for me in degrees. So here we've got 8 sectors. We know 360 is the total all the way around. So really, if I divide by 8, 368 ways, we're going to get 45. So that'll be good to know for this activity, that 45 degrees is each one of these sectors. Same thing here. If we have 360 all the way around, we're going to divide by 12 and get 36 degrees for every single sector. That's wrong. We're going to get 30, not 36. 30 degrees. Okay, so what this activity was meant to be was they give you a bunch of cards with radians on it, and based on the number of radians, you shade in however many spots you think should be shaded in. So the first one we're given is pi over 2. All right, so where would you shade pi over 2? Let's say we're going to start with circle 1. How many sectors would it take for me to shade in pi over 2 radians? Well, hopefully you know that pi over 2 is really just 90 degrees. Or you could say pi over 4 plus pi over 4 is going to be pi over 2. So that'll be 2 sectors over here. And you'll notice it makes a right angle with the 2 radii. All right, the next one we're given is pi over 3. So let's look at circle 2. If each one of these is pi over 6, and I want pi over 3, how many would I be shading in? Well, one way you could look at it is that pi over 3 is just double pi over 6, so that's 60 degrees. So if each one of these is pi over 6 and I'm doubling it, I'm going to fill in 2 of these. Okay, the next one we have is just a pi over 4. That one's easy. Just going to be one of these sectors. All right, and again, we couldn't use pi over 4 on its own in circle 2 because I can't multiply pi over 6 by an integer to get pi over 4. I can't double it or triple it, right? Because it's just not going to go into it. We're going to have pi over 6, then 2 pi over 6, 3 pi over 6, 4 pi over 6. None of those convert to pi over 4. All right. Next radian measure they give is pi over 12. So this one is kind of tricky. There are a couple of different ways you could think about it. First off, let's start with circle 2. If I had a radian measure of pi over 12, how many of these arcs would that take up? Well, if one is pi over 6, that means that half of that is going to be equal to pi over 12. So I'm going to sort of estimate here. We're going to get about halfway through one of these here. Thinking in terms of degrees, if I've got pi over 12, again, that's half of pi over 6, which we said was 30 degrees. So half of 30 degrees is 15 degrees. Pi over 12 is pretty rare. I wouldn't say that we see that too often, but I guess it's good to know. All right. Alternatively, you could have thought that pi over 12 was a third of pi over 4, right? 45 divided by 3 is also 15. So we could have shaded in a third of one of the sectors here. Okay. Let's just put in another pi over 12. I don't really love that. I like to just want to stick with the whole shade of the sector. All right, next one we have is just pi. So either circle, actually just stick with circle 1 here. If I were to fill in pi of these pi radians, additional, how many sectors would that be here? Well, pi is really just 180 degrees, so that would be half of the circle, a semicircle, or 4 of these areas shaded in. Okay, and then let's add one more, pi over 6. So we're just going to fill in one more over here. So now we get to something, I guess, a little bit more interesting. Sorry, that activity really doesn't work too well remotely. But hopefully you saw that when you're thinking in radians, you're really trying to break up into nice even degree measures. 30 degrees, 45, 60, 90, 180. Like I said, rarely you'll see 15. But those numbers are all sort of multiples or factors of one another, or they have a common factor. So that's how we sort of try and break up the radians. Very rarely will they say convert 20 degrees into radians, or 22 degrees. Very often it'll be 30 degrees, 45, 90. So just to familiarize yourself with those radian measures. Okay, what is the central angle measure for the remaining unshaded sector? So let's do that for both. For circle 1, let's do this. It'll be question number 1 down here. Circle 1 and circle 2. So they want unshaded. So if we look at this first circle 1 up here, what is that central angle measure? Well, we know it's pi over 4 radians. But what is that in degrees? And hopefully at this point, pi over 4 should just jump in your head to be 45 degrees. The way I remember this is that this fraction has a 4 in the denominator. So that's how I remember it associates with 45 degrees. We're also cutting 180 into 4 equal parts, which would be 45, or a lot of different ways you remember it. For me, the easiest, 4 in the denominator, that's 45 degrees. Circle 2, for unshaded. Well, we know we've got a semicircle here, so that makes up pi total radians. Then we've also got two additional ones. So that's pi over 6 and pi over 6. So pi plus pi over 6 plus pi over 6. Right, this would be easiest if we had like denominators. So I'm going to switch this one to 6 pi over 6. Add them all up, and we get 8 pi over 6, which is also equal to 4 pi over 3. If you remember, pi over 3 is 60 degrees. So if I have 4 pi over 3, that's 4 times 60 degrees, or 240 degrees. So those are quick ways you can convert between radians and degrees. All right, number 2. What is the central angle measure for the block of unshaded sectors? Well, we know that the entire circle is going to add up to, for shaded, it's going to add 360. So if this one was 45, the other one's just going to be 360 minus 45, or 315. You can use the same logic here. If this is pi over 4, and the entire circle is 2 pi, well then, what's 1/4 less than 2? That would be 7 pi over 4, because 8 pi over 4 would just be equal to 2 pi. We're taking away 1/4 of pi, so we're taking away one of those 2 pi's there. Again, this is because 2 pi is the same as 8 pi over 4. Additionally, I could just say 1, 2, 3, 4, 5, 6, 7. Those are 7 sectors, so 7 pi over 4 is 7 pi over 4. All right, circle 2. Central angle measure for the block of shaded. So if this was 240, it'll be pretty easy to just do 360 minus 240. That's equal to 120. Another way we can look at it, if this is 4 pi over 3, I know 2 pi is equal to 6 pi over 3, because 6 divided by 3 is 2. So I know there's 6 in total. I've used 4 of the thirds. So that means there are 2/3 remaining. So 2/3 pi would be my equivalent amount of radians. We also know if I have 120 degrees over here, that's really the same as saying 60 plus 60. You may have memorized by this point that 60 is equal to pi over 3 radians. And then pi over 3 plus pi over 3 is 2 pi over 3. I know I'm doing a lot of stuff that just seems like, oh, I just know this. That's only because I've had a lot of practice with it. Unfortunately, this is just one of those topics that you need to sort of do a lot of problems with, so that you just recognize just these equations. Pi over 3 is 60, pi over 2 is 90, pi over 4 is 45. Once you get those few down, it'll really come a lot easier. Pi over 6 is 30. Really, those are all the ones you need to know. All right, that's it for 12.3. Enjoy the rest of your day.